Example 4, find the integral of sine to the fourth power x dx. Solution, we could evaluate this integral using the reduction formula for the integral of sine to the power n x dx. Equation 7.1.7 together with example 3 as in exercise 7.1.47, but a better method is to write sine to the fourth power x equals open sine squared x close to the power squared, and use a half angle formula. The integral of sine to the fourth power x dx equals the integral of open sine squared x close squared dx equals the integral of open 1 minus cosine 2x over 2 close squared dx equals 1 over 4 times the integral of open 1 minus 2 cosine 2x plus cosine squared 2x close dx. Since cosine squared 2x occurs, we must use another half angle formula. Cosine squared 2x equals 1/2 open 1 plus cosine 4x close. This gives the integral sine to the fourth power x dx equals 1 over 4 the integral open bracket 1 minus 2 cosine 2x plus 1/2 open 1 plus cosine 4x close bracket dx equals 1/4 the integral of open 3 over 2 minus 2 cosine 2x plus 1/2 cosine 4x close dx equals 1 over 4 open 3 over 2 x minus sine 2x plus 1/8 sine 4x close plus big C. To summarize, we list guidelines to follow when evaluating integrals of the form the integral sine to the power m x cosine n cosine to the power n x dx, where m is greater than or equal to 0 and n is greater than or equal to 0 are integers. Strategy for evaluating the integral of sine m sine to the power m x cosine to the power n x dx. Part A, if the power of cosine is odd, open n minus 2k plus 1 close, save 1 cosine factor and use cosine squared x equals 1 minus sine squared x to express the remaining factors in terms of sine. The integral of sine to the power m of x cosine to the power 2k plus 1 of x dx equals the integral sine to the power m x open cosine squared x close to the power k cosine x dx equals integral of sine to the power m of x open 1 minus sine squared x close to the power k cosine x dx. Then substitute u equals sine x. Part B, if the power of sine is odd, open m equals 2k plus 1 close, save 1 sine factor and use sine squared x equals 1 minus cosine squared x to express the remaining factors in terms of cosine. The integral of sine to the power 2k plus 1 x cosine to the power n x dx equals the integral of open sine squared x closed to the power k cosine to the power n x sine x dx equals the integral open 1 minus cosine squared x closed to the power k cosine to the power n x sine x dx. Then substitute u equals cosine x. Note that if the powers of both sine and cosine are odd, either part A or part B can be used. C, if the powers of both sine and cosine are even, use the half angle identities. Sine squared x equals 1/2 open 1 minus cosine 2x close, and cosine squared x equals 1/2 open 1 plus cosine 2x close. It is sometimes helpful to use the identity sine x cosine x equals 1/2 sine 2x. We can use a similar strategy to evaluate integrals of the form the integral of tangent to the power m x secant to the power n x dx, since open d over dx close tangent x equals secant squared x. We can separate a secant squared x factor and convert the remaining even power of secant to an expression involving tangent using the identity secant squared x equals 1 plus tangent squared x, or since open d over dx close secant x equals secant x tangent x, we can separate a secant x tangent x factor and convert the remaining even power of tangent to secant. Example 5. Evaluate the integral of tangent to the 6th power x secant to the 4th power x dx. If we separate one secant squared x factor, we can express the remaining secant squared x factor in terms of tangent using the identity secant squared x equals 1 plus tangent squared x. We can then evaluate the integral by substituting u equals tangent x, so that du equals secant squared x dx. The integral tangent to the power 6x and secant to the power 4x dx equals the integral of tangent to the power 6x secant to the power 2x and secant to the power 2x dx equals the integral of tangent to the 6th power x open 1 minus tangent squared x close secant squared x dx equals the integral of u to the power x open 1 plus u to the power 2 close du equals the integral of open u to the 6th power plus u to the 8th power close du equals u to the 7th power over 7 plus u to the 9th power over 9 plus big C equals 1 over 7 tangent to the 7th power x plus 1 over 9 tangent to the 9th power x plus big C.